we were just talking about 2 to the x, so that when you have a base of 2, that is called the doubling function. I want to just circle back and talk about the interest formula that we worked with in chapter 4. We worked with an interest formula that was for compound interest. And in the parentheses, you had 1 plus r over n. And if you let n equal 1, 1 plus r, if r were equal to 100%, then we have the doubling function. So some of us might be asking, why are we studying chapter 8 with chapter 4? And the reason is because we were just looking at exponential growth, and the book just has that separated exponential growth in a different chapter. So that's why we're folding these together. This is just taking a number times 200% to a power though. So this idea from chapter 4, 200% is simply 2. And so what we were just working with is very similar to that material from before. It's just that our rate is 100%. Okay, I'm going to get into the penny savings challenge just a little bit, but you still do need to read the book to answer some of the questions. I think there are questions about leprechauns in your homework, so I'm going to refer you to the book for those. I do want to get you thinking about it though. So assume that you start saving a penny today. You'll have 2 pennies tomorrow, and consider doubling for as long as possible. I want you to consider this will go to 4 cents, 8 cents, 16 cents, 32 cents, 64 cents, and then you'll continue this over and over. This wouldn't be feasible to do long term. It would be more than your income. And that's what I want to get you thinking about right now. My second question to get you thinking, how much do you think you might save after 15 days? After 30 days, and then after 1 year. And to make sure your mind is in the right spot, this is not what I'm talking about. I'm not saying you have 1 penny and then 2 pennies and then 3 pennies and then 4, because this is an absolute change. This is linear growth. You're adding a penny every day. I'm not referring to that type of growth. I'm referring to exponential growth where we have doubling. And it may surprise you, but by the 14th, 15th day, you'll have to be saving over $150 just by the 15th day. So by the mid of the month, so think about Ides of March. By the Ides of March, you'd already be, if you had started on the 1st, you'd already have to save for that particular day $150. By the 30th day, you are in the trillions already. So by the 30th day, you're already saving in the trillions. That should surprise you. I think I have a meme here. This is massive. By 1 month, you're already in the trillions, and that's why this wouldn't be feasible. I made a little Google sheet to show you how big these values get. On the first day, if you have 1 penny, 2 days, 2 pennies, 3, etc., and you can see the values I used to make that chart. By 100 days, you can see how large these numbers get. These are massive. This is how exponential growth works. So those numbers get large very fast. And this is one of the penny problem is an additional story that you're going to read in chapter 8 in section 8A. This should remind you of compound interest. So we've talked about this before. The reason we're discussing this is because compound interest is an exponential function. That time for years is in the exponent. And so overall, this is an exponential function. That's why we gain money over time just by having it in there, because the bank is paying you some amount of interest. Now, certainly we might have a smaller R than a doubling function. You're not going to find a savings account with a doubling rate, but it is overall, it's still an exponential function, and that's why we're getting that interest that adds on over time. And why I want you to remember to start savings for your retirement early.